x minus a, take negative common and a square common, so f of x minus f of a upon x minus a, and limit x tends to a. We can write the limit separately. Now a square minus b square, a minus b, a plus b. So here we get limit x tends to a, x plus a, f of a minus a square. Limit x tends to a, f of x minus f of a, x minus a. That is equals to f dash a. Now put the limit here, a plus a, 2a f of a minus a square f dash a. So this is the value of this. Now the next one. For what choices of a and b is the function f of x, x square, x is less than equals to c, ax plus b, x is greater than c, is differentiable at x is equals to c. It is given that the function is differentiable at x is equals to c. अगर फंक्शन डिफरेंशिएबल है, इट मींस द फंक्शन इज कॉन्टिन्यूअस आल्सो, कॉन्टिन्यूअस एट x इज इक्वल्स टू c. और अगर कॉन्टिन्यूअस है तो कॉन्टिन्यूअस की क्या कंडीशन थी? लिमिट x टेंड्स टू c नेगेटिव, f of x is equals to limit x tends to c positive, f of x is equals to value of function at that point, x tends to c negative, then the value of function is x square. When x tends to c positive, value of the function is ax plus b, and f of c is c square. So what we get? C square is equals to ac plus b is equals to c square. Now it is given that the function is differentiable. अगर फंक्शन डिफरेंशिएबल है तो लेफ्ट हैंड डेरिवेटिव और राइट हैंड डेरिवेटिव इक्वल होंगे. लिमिट x टेंड्स टू c नेगेटिव, f of x minus f of c upon x minus c is equals to limit x tends to c positive, f of x minus f of c upon x minus c. Is it clear? अगर फंक्शन डेरिवेबल है तो उसकी लेफ्ट और राइट हैंड डेरिवेटिव इक्वल होंगे. Now f of x when x tends to c negative is x square, f of c is c square, limit x tends to c is equals to f of x when x is greater than c, ax plus b, f of c is c square upon x minus c. A square minus b square, a minus b, a plus b. So here we get x plus c, x minus c upon x minus c. It will get cancelled here. Limit x tends to c, ax plus b minus c square upon x minus c. Now using 1 here, it is given that c square is equals to ac plus c. So we can write it as ax plus b minus ac minus b. B will get cancelled. Take a common, x minus c upon x minus c. It will get cancelled here. Or here we have left with, put the value c plus c is 2c. So 2c is equal to a. Put the value of a, let it be equation 2. Put the value next one. Next question is, if f of 2 is equals to 4, f dash 2 is equals to 1, then find limit x tends to 2, x of f2 minus 2 of fx upon x minus 2. Now using definition of derivative, f dash 2 is equals to limit x tends to 2 f of x minus f of 2 upon x minus 2. यही डेफिनेशन कहती है कि f dash x is equals to जिस पॉइंट पे हमने डिफरेंशिएबिलिटी चेक करनी है. So by using definition of differentiation, now we want to find this, so we can write it as x f2 minus 2f2 plus 2f2 minus 2 f of x upon x minus 2. So take f of 2 common from here, so x minus 2 f2 limit x tends to 2 upon x minus 2, take 2 common, minus 2 common, f of x minus f of 2. We can separate these terms, so we can write it as x minus 2 upon x minus 2 minus 2 limit x tends to 2. X minus 2 will get cancelled here. F of 2, we have value of f of 2 as 4 minus 2 into, this is f dash 2. And value of f dash 2 is given, that is 1. So 4 minus 2, that is 2. Now the next one, discuss the differentiability of the function f of x into modulus of x at x is equals to 0. We want to discuss the differentiability at x is equals to 0. Now write the function as when x is less than 0, x is greater than 0. When x is less than 0, modulus of x has value minus x. So we can write it as this. Modulus of x is minus x. So minus x into x minus x square. When x is greater than 0, modulus has value positive. So this is the value. Now left hand derivative, limit x tends to 0, f of x minus f of 0 upon x minus 0. When x is 0 negative, then f of x is value minus x square. F of 0 is 0, x minus 0. So what we get? Limit x tends to 0, minus x square upon x. So we get value as 0. Now right hand derivative, limit x tends to 0 positive, f of x minus f of 0. When x is greater than 0, value of the function is positive x square, f of 0 upon x minus 0, limit x tends to 0. So what we get? Limit x tends to 0, x square upon x, that is x. After putting the limit, 0. Now left hand derivative is equals to right hand derivative. So it is differentiable at x is equals to 0. Now the next one, discuss the continuity and differentiability of the function f of x as 1 minus x, x is less than 1, 1 minus x, 2 minus x, 1 is less than equals to x, less than 2, x is greater than 2, then the function has value 3 minus x. Now for x is less than 1, f of x has value 1 minus x. We know that polynomial function is continuous everywhere. Polynomial function is continuous. Polynomial function is continuous and differentiable. Therefore, for x less than 1, function is continuous and differentiable. Clear? Now for x greater than 2, f of x is 3 minus x. Again, polynomial function, continuous and differentiable. So जब x की वैल्यू 2 से बड़ी होगी और 1 से छोटी होगी, then the function is continuous and differentiable. Now we want to check the continuity and differentiability at point x1 and x2. अगर हमने फंक्शन को डिफरेंशिएबल प्रूफ कर दिया तो फंक्शन कॉन्टिन्यूस तो होगा ही. So let us check the differentiability at point x1 and x2. कॉन्टिन्यूटी के लिए अगर हम चेक करें, लिमिट x टेंड्स टू 2 नेगेटिव f of x, फर्स्ट 1 में कॉन्टिन्यूटी चेक करते हैं. लिमिट x टेंड्स टू 1 नेगेटिव f of x, x is 1 negative, then the function has value 1 minus x, so 1 minus 1 is 0. So limit x tends to 1 positive f of x, then the function has value 1 minus x, 2 minus x. Put the limits 1 minus 1, 2 minus 1, 0 into 1, 0. Value of function at point 1, 1 minus 1, 2 minus 1, 0. So the function is all are equal. Left hand limit is equals to right hand limit is equals to value of function at that point. Therefore, fx is continuous at x is equals to 1. Now let us check the continuity at x is equals to 2. Left hand limit x tends to 2 negative. When x is less than 2, then the function has value 1 minus x, 2 minus x. 1 minus 2, 2 minus 2, 0. Now when x is greater than right hand limit 2 positive, x is greater than 2, then the function has value 3 minus x. So 3 minus 2, that is 1. Value of function f of greater than 2 के लिए हमें फंक्शन कॉन्टिन्यूस दिया है, यहाँ पे इक्वलिटी साइन है. सो f of 2 will be 1 minus 2, 2 minus 2, 0. Therefore, the function is not continuous at x is equals to 2. Function is continuous at x1 but not continuous at x2. Now let us check the differentiability at x is equals to 1. Left hand derivative, limit x tends to 1 negative, f of x minus f of 1, x minus 1. So f of x has value 1 minus x, f of 1 equals to 1 के लिए f of 1 हमारे पास क्या है? f of 1 has value 0, 0 upon x 1. Now right hand derivative. Limit x tends to 1 positive, f of x minus f of 1 x minus 1. When x tends to 1 positive, then f of x is 1 minus x, 2 minus x. F of 1 has value 0 upon x minus 1. Take negative sign common. Minus x minus 1, 2 minus x, x minus 1. Put the limit now, 2 minus 1. 2 minus 1 is 1, so negative 1. So left hand derivative is equals to right hand derivative. Therefore it is differentiable at x is equals to 1. जो फंक्शन है x is equals to 1 पे continuous भी है और differentiable भी है. Now since the function is not continuous, हमने क्या कहा था, जो differentiable function है वो continuous भी होगा, और अगर function continuous ही नहीं है तो वो differentiable भी नहीं होगा. Since function is not continuous at x is equals to 2, therefore function is not differentiable at x is equals to 2. Clear? जो भी फंक्शन डिफरेंशिएबल होगा वो कॉन्टिन्यूअस भी होगा. तो अगर फंक्शन कॉन्टिन्यूअस नहीं है तो डिफरेंशिएबल भी नहीं है. नाउ नेक्स्ट वन. If f of x is equals to x square plus 3x plus a for x is less than equals to 1 and x greater than equals to 1, function has value bx plus 2 is everywhere differentiable. Find the values of a and b. Now it is given that function is everywhere differentiable. Now for x is less than 1, f of x is x square plus 3x plus a. For x is greater than 1, f of x is bx plus 2. These are polynomials and polynomials are differentiable everywhere. So f of x is differentiable for x less than 1 and x greater than 1. Now we have to check the differentiability at point x is equals to 1. So left hand derivative, x tends to 1 negative, f of x minus f of 1 x minus 1. When x is less than 1, function has value 3x plus a, f of 1 is 1 square plus 3 into 1 plus a. So a plus 4 upon x minus 1. Limit x tends to 1. So what we get? A will get cancelled. Limit x tends to 1. X square plus 3x minus 4 upon x minus 1. Now हमें ये given है कि fx is differentiable everywhere. So left hand derivative और right hand derivative equal होंगे. अगर differentiable है तो ये continuous भी होगा. First put left hand derivative is equals to right hand derivative. So left hand derivative we get x tends to 1, x square plus 3x minus 4 upon x minus 1. Right hand derivative is when x is greater than 1, bx plus 2 minus f of 1 is a plus 4 upon x minus 1. Clear? Now factorize this term. On multiplication, we want minus 4 and addition 3. So we can write it as x square plus 4x minus x minus 4. X plus 4 minus x plus 4. So the factors are x plus 4 and x minus 1. Now limit minus a minus 4 upon x minus 1. X minus 1 will cancel here. So x plus 4, put the limit here, 1 plus 4, 5. Write it as it is, this term. Now since the function is differentiable everywhere, therefore the function will be continuous. Since fx is differentiable at x is equals to 1, therefore it is continuous at x is equals to 1. तो continuity की क्या condition है? Limit x tends to 1 negative f of x is equals to limit x tends to 1 positive f of x is equals to value of function at that point x tends to 1 negative. Then the function has value x square plus 3x plus a.